see if we're live yet. All right, we are live. Okay, so let's talk about some lines, some transversals. I don't even know what I'm saying. Telling you, tired. So we are looking in parallel and perpendicular lines. We're looking at lesson 21 today. Nope, not 21, 22. We're looking at lesson 22. Okay, so available for your use, you have the Using Transversals Read It, where you can read all about transversals and how to use them. You have There Watch It. I haven't watched it. I don't know if it's good or not. It could be way better than mine. I don't know. Check it out. Then you have the Practice It that we're going to look at. I don't know where that comes from. We're going to look at this one. And then the Show It is what you're going to do today. Okay? Everybody good? All right. So let's look at this Practice It together. And then get y'all where you can work on your own. So here's what we've got to start with. Move this down out of the way. So all of this colorfulness over here, all that stuff, that's just how to attack a problem, right? So the very first thing is what's the problem statement? So that means, what are you looking for? So what are we looking for in this problem? What is our problem statement here? What are we trying to find? Well, that's true. But that's not what we're trying to find. What are we trying to find in this? What is the actual problem? What's the problem here, Payne? In this one, what's the problem? What are we looking for? Finding angle 1 and angle 2. That's our problem, right? So the problem statement is, what is angle 1 and what is angle 2? Good morning. You just now getting to school? Oh, gotcha. I didn't realize you were in homecoming. Yes, ma'am. Go right ahead. Okay, so the second part is, what do you know? So let's look at these diagrams and decide, what do we know? Okay, what do we know based on this? Let's list everything we know. What do we know?
What's that number?
Which number? This? That's 52 degrees right there. Let me see if I can make it bigger. Oops. Y'all know what you can't do? You can't go full screen. You can't go full screen and half screen at the same time. Yep, that's not going to work. So, sorry. So what do we know? Let's talk about what we know here.
1 is 52.
We know that. We do know that, but I don't want to say that yet. What do we know about the relationship between 1 and this angle up here? What is their relationship to each other? It's the one that's hard to remember. Corresponding. So they are corresponding angles. We know 1 and 52 are corresponding angles because we know that K is parallel to M, right? What do we know about 2? Does it have a relationship with somebody? What? What? I just don't know what you...
Not an angle. You can justify that. Wouldn't that be the same thing?
Is 2 going to be 52?
They're adjacent.
Okay, but does adjacent mean congruent?
No.
No. But what were you saying, Josephina? What kind of relationship does angle 2 have with other things?
Supplementary.
They are. 1 and 2 are supplementary. They make a linear pair, right? They make a line, so they are supplementary. This 1 and 2 right here are supplementary, right? Okay, now let's apply what we know, right? I don't want to do that. Let's apply what we know. So Payne's already told us that angle 1 is going to be 52. How did he know that? Well, because he knows corresponding angles are congruent. So if 1 and 52 are congruent or corresponding, they are congruent. Now, can you find 2? What would we do to find 2?
180 minus 52.
We would do 180 minus 52, right? And that's going to get you what? Y'all math. Good mathing. 128. Yeah. Good mathing. So that one is 128. Now does this angle 52 and 2 have a relationship to each other that we can identify? They don't. Remember, 52 and 2 are related to 1, but from different directions. So 1 is like their shared cousin. Like they share that one. You know, like how you have a cousin that has cousins that aren't related to you. So you and those other people share that one cousin. You know what I'm talking about? I know you know what I'm talking about. So this is you. This is your cousin. But then they have these other people that are their cousins. But you are not cousins with those other people, right? But this guy here in the middle is your shared cousin. You'll both share him. So you're both related to him, but you're not related to each other. Well, that's how 52 and 2 are. They're both related to 1, but they're not related to each other, right? Okay, let's look at this one. We're going to only do one of these because it's so simple. I mean, it's so basic. And it's really not the meat of what we need to be looking at. But I do want to do one. So we've got parallel lines, right? 1, 2, 3, 4, 5, 6, 7, 8. And they gave us a measure for one of them. What'd they say? Angle 1 is 115. So this angle is 115. So knowing that's 115, what else do we know?
Oh, I can do it. I mean, 4 is 115.
How do you know?
Because they're vertical.
Because they're vertical. Okay.
And then if 1 is like, then 1 and 5 is corresponding.
They're corresponding, so that one's 115.
And then 4 and 8 is corresponding.
So we can say 4 and 8 are corresponding because it's 115, or we could say 5 and 8 are vertical, or we could say 1 and 8 are alternate exterior, right? So those are, we can get 8 so many ways, it's crazy.
And then we know that 8 and 7 is supplementary.
They are supplementary.
We just subtract 180 from 115.
So 180 minus 115. So 180 minus 110 would be 70. Take another 5 off, that's 65. Okay?
Then that means 6 is 65.
Because?
Vertical.
Vertical, okay.
Then we know 6 is corresponding to 2.
So they're 65.
And 3 is vertical.
Now, I do also want to point out that 3 and 6 are also alternate interior. So since they're alternate interior, they're also congruent, right? Excellent job. Okay, so we are not going to do that one because it's exactly the same stuff, but let's look at this one. This one looks scary, don't it? I'm going to try to draw it, and it ain't going to be pretty. Okay, so here's what we've got here. Notice this little symbol here and this little symbol here. What does that mean? What do those two little symbols mean?
They're parallel.
It means they're parallel, right? So that tells us that this line and this line is parallel. Now, if we extend this on out, when you draw a line like this, a little dotted line, it's called an auxiliary line. And it just helps you visualize what you're looking at, right? So if we extend that line on out, then you'll know that these angles right here and these angles right here are going to be congruent to each other, right? And then the same thing here. We've got this set of angles up here and this set of angles up here that are congruent to each other, right? Everybody with me? You'll see what I'm saying? Well, so I really don't have anything going on with this one, right? This guy right here, I'm not really looking at. I'm really just looking at these two parallel lines and this one transversal right here. Because all of my angles are on that transversal. Y'all see what I'm talking about? So tell me about the angles we have and what sort of relationships they have to each other. The angles that we have information about. Like y and x. What do we know about y and x? They're supplementary. So we know, and we can write y plus x equals 180, right? What do we know about y and 3x. They are on the same side, but that's not going to get me a whole lot. Look at where they're at. They are not both interior, so we can't call them interior or exterior, right? Because one's in, one's out. But look where they're located. They're in the same spot. What's the name for that? Come on, Payne. I know you know it. It's the hard one. Corresponding. When they're in the same spot, they're called corresponding. And we know that corresponding angles are congruent. So that tells us that y equals 3x, right? Now, x and 3x, they don't have a relationship. They're on alternate sides. One's interior, one's exterior. They're not corresponding. They don't have anything. But y'all look at this. Y'all see how that says y equals 3x? So up here where y is, could we not just replace that with 3x? Y'all remember doing this last year? So this is why I was giving y'all algebra stuff last week to practice on. Because we're fixing to hit it heavy and hard using algebra in geometry. Okay? So 3x plus x equals 180, right? And all we did was replace the y with 3x. And now we're going to solve it. So 3x plus x is... Okay, and then divide by 4. Y'all remember that? I know I'm not doing a very good job writing. I'm sorry. That's gone. What's x equal? 45. So x is 45. Okay. How do I find y?
180 minus 45.
That's one way. I could do 180 minus 45. What's my other way? What does y equal? 3x. So I can do 45 times 3. Either way, we're going to get the same answer. Either way, right? Okay. Does that make sense? Look at this one. Tell me what you know. What you know, what you know.
That wherever that right angle comes, that's 90.
That's 90. What are lines that cross at 90 degrees called? Start with a P. Perpendicular. What's funny is Trey just shouted out parallel.
Did you say lines that are...
Right. You just shouted out parallel. I'm not making fun of you for saying it. I'm making fun of you for the second you realized that was a dumb answer. Right? Like I saw it on your face. I actually saw you mouth it. Right? Okay. So lines that cross at a right angle are perpendicular. That's what they're called, right? What does those little arrows represent? These little guys right here? What do these mean? Parallel. So we know these are parallel, right? We know this crosses at 90 degrees. So what does that tell us about these angles and these angles? What do we know about them?
Wait, no, they're interior alternate.
Okay. You are right, but that's not what I asked. So I'm going to re-ask my question, okay? You are correct in your statement, but that was not the question that I asked. So I'm going to draw this out, okay? And we know that that is terrible, Liana. Jeez, what is wrong with me? Those are, gosh, I can't even with myself. Those are parallel, those lines, right? What do I know about this set of angles and this set of angles? Since these lines are parallel. They're all the same. So they correspond. They correspond to each other, right? Okay. So now back to what Payne said. What is the specific relationship between those two angles? The one with the 90 and the one with the 8x plus 2. Alternate interior. Which we know what about alternate interior angles? They are the same. So we can write us up a little algebraic equation. 8x plus 2 equals 90. And then just solve it. So we're going to subtract 2 from both sides. We got 8x equals 90. Nope, 88. And then we're going to divide both sides by 8. And x is going to be 11. So if the question is what is x, we're done, right? What is that angle measure, by the way? 8x plus 2. What is the angle measure? It's 90. That was a trick question. I was waiting for y'all to be like, but you figured it out. Okay. I want to talk about this one for just a minute. So we've got this shape, right? We got this shape. And normally when you see something like this, you kind of freak out on me a little bit because you don't know anything about these things, right? But I want you to take away the fact that it's a shape. Forget that it's a shape for a minute and tell me just what you see. What does this diagram have? You've got parallel lines, right? So you've got this line here and this line here that are parallel. What else does this diagram have? It's got a transversal. So this right here, we can extend it in both directions, right? That's a transversal. That's all that is a transversal. If we extend this and we extend this, we're just dealing with two parallel lines and a transversal. So don't freak out just because it looks like a shape that we haven't talked about yet. Look at what does that. If you break that diagram down, what's in that diagram? What are you seeing, right? Now tell me about these two angles. They are supplementary. That is a true statement. What's their relationship? Nope.
Same side?
Same side, or the other word we use is consecutive, right? Same side or consecutive, interior. Y'all had the interior down. Y'all just couldn't get the same side. And same side interior angles are congruent, just like one of y'all said. So 6x plus 2 has to equal 112. And then we're just going to solve that basic equation. Okay, so what do we do? Minus 2. 6x equals 110. Divide by 6, Payne says. He sounds very confident in himself. I don't know what that is either. Anybody else know? 18.3 repeating. Do y'all know what 0.3 repeating is as a fraction? Just out of curiosity.
1/3.
1/3. Boom. Hey, bonus question. What's 0.6 repeating as a fraction? 2/3. Look at y'all. Got some smarts going on. All right.
I was about to say 1/6.
Well, 1/3's right.
I know, but you said what's repeating.
Mm-hmm.
I was about to say 1/6.
Well, now that wouldn't make any sense. Because that'd be smaller than 1/3. Yeah. Okay. Now, your lesson today is going to be the show it activity for this, right? It should be the next activity. You do have an interactive worksheet. Quick reminder, if the interactive worksheet won't work, type answers in Buzz. Don't tell me, well, I didn't have any way of submitting it, because you're a liar. Just type your answers in Buzz. I make that option available every time, okay? The interactive worksheet is to help you not have to type your answers in Buzz, but mostly to help me grade it. I don't mind hand grading. I'll grade by hand. Yes, sir.
There's two.
What do you mean?
There's transversal and there's using transversal.
Both. They'll take you like maybe 5 minutes max each. Maybe. Okay, so you need to do them both.
Wait, wasn't this one we were supposed to do yesterday?
Yep. Okay, so I'm going to end this stream. End this stream.